Hello and welcome to another video. Today we're going to be continuing on with the Typescript blind 75, and so we're going to be doing longest substring without repeating characters. And in this problem, you're given a string and you're asked to find the longest substring without repeating characters. So we'll just briefly go through the algorithm. So in the first one, the longest substring is ABC, and there's a couple of them. So there's one here, there's one here. In the second one, since it's all B's, the longest substring is just one letter B, and then in the third one, it is WKE. So just a brief explanation of the algorithm. Essentially, we're looking for a contiguous sequence without repeating characters. So if we have something like this, what we can do is we can just have a set that stores all of the letters we currently have, and then if we ever run into a letter that we already have, then we will be deleting letters that we have until we no longer have it. So let me just quickly show you what that looks like. So let's say for like this problem, we are going to have a set, and we're going to have a left and right we're going to have a sliding window here, and I'm just going to represent that with a moving line. So like a line like this means the right is over here and the left is over here. And then we're going to simply have a result, and then every time there is a valid substring, we're going to update our result. It'll start at 0. So like we're going to go through here. We're going to add A to our set because A isn't in there yet. Now we're going to go here. We're going to check, is B in our set? No, it's not. So we're going to add B to the set. And by the way, as we do this, we update the result. So in the first one, it's going to be 1. Then it's going to be updated to 2. Now here, we're going to check, is C in our set? No, it's not. So we're going to add C to our set. Okay. Now we're going to update this to 3. Now here, we're going to check, is A in our set? Yes, it is. So every time we have something that is in our set already, that means we have a duplicate. So what we're going to do is we're going to say, okay, if A is in our set, let's just keep removing things from the left until A is no longer in our set. So what's going to happen is, let's say this will be the things we remove. So we're going to remove this A, and now our window is this blue part. So if we remove the A, we're going to get rid of it from the set. And then we're going to check, is A in our set still? No, it's not. So now we don't have any more repeated characters, but we're going to add it back in. Because in this case, A is over here, but A could have been like over here, and then we would have had to remove the whole thing. So it's not necessarily going to be the first character you encounter, so you can't just say, like, let's remove the first character you encounter. Okay. So now we have a valid string again, and let's keep going. So we're going to check, is B in our set? Yes, it is. So we're going to remove B from our set. So when we remove B from our set, and once again, we happen to run into the case where that was the first character we ran into, but that's not always going to be the case. Okay. And so now we're going to add B back in because we have a valid string, right? This is a valid string. So we're going to add B back in. Then we are going to keep updating the result, but there's nothing bigger than 3 so far, so we don't need to update anything. Okay. Now for C, we're going to check, is C in our set? Yes, it is. So we're going to remove it. And then we are going to keep deleting letters until we run into... So actually, sorry, we're not going to remove the C when it is. We're going to keep deleting letters until we hit the C, right? So we're going to delete this C, and that we did hit the C. So we're deleting letters until the character we delete matches the character we're on, essentially. And we just happen to do that right away for all of these. But like I said, it's not always going to be the case. Okay, so now we have to add the C back in. So we're deleting until this character is no longer in our set, and then we add that character in, is essentially our operation. Okay, now we will increase this, and we're going to see, is B in our set? Yes, it is. So we have to keep deleting characters until B is no longer in our set. So this will kind of show you, worst cases. So we're going to delete this A, but B is still in our set, right? Like we have to delete until these two characters match. So now these two characters do match, and we will delete B as well. So we'll delete B, and now finally we have a valid string, and then we're going to add B back in. And actually, I guess what you could do is an optimization now, thinking about it really quick. So when these two characters match, instead of just you keep deleting characters, you can just check if these two characters match, then we have a valid string. So you can just, like, instead of deleting and adding it back in, you can just stop your like deleting right there. So that would work as well. So we can write that down. So add chars till we have a char that is in the set if we do delete chars until the left character is the right character, and then increment left by one more, right? So like if this is our right character, we're going to hit the case where the left character is over here, and we're going to say, okay, they match now. So once we move the left one more time, then we're not going to have any more duplicate characters. Because all of our states before that were all unique characters, so when we hit a character that matches, we only have one duplicate, so we just have to get rid of that one. So we could do that slight optimization where instead of deleting and adding the same character over and over and over, we'll just say, let's just keep deleting until these two match, and then when they match, move the left over one more time. And remember, in this blue, the left is the leftmost character, and the right is the rightmost character. Okay, so let's demonstrate that here for this example. So we will add a character here. We'll say, okay, is B in our set? Yes, it is. So let's just keep deleting the left until they match. So does the left and the right match? No, they do not. So let's just delete the left. So we're going to delete this C. Okay, and then we're going to move this left. So now the left is over here. And do the characters match now? Yes, they do. And so we have to move the left over one more time to over here. And we don't have to like delete and insert every time. And so the biggest thing we ran into was 3, so we're going to return 3. And you could do the same thing for these, but essentially it's all the same. You literally just make a set, and anytime you run into a character that's in your set, you will just have to keep deleting characters until you have a match, just to make sure that you no longer have that duplicate. Okay, so now that we know that, let's actually get into doing this in TypeScript. So I actually copied this over already. And a small change I made compared to the two-sum problem was in my config, I got rid of the undefined thing. So I think one of these was an undefined, checks for undefined. So let me look for that actually. I'm not seeing that. Let's talk about that. Undefined. So here it is. So this is the one I got rid of because the annoying thing about this was like anytime you're indexing into an array, it's like elements can be undefined. So it just gives you non-stop issues. And I think that's a little bit unrealistic, especially for smaller programs. So I got rid of that. But everything else, we're going to follow strict TypeScript logic compared to LeetCode. So let's do that. So let's take a look at our issues first. So S is declared and never read, which is fine. And then it says we need to return a number, but we are not returning anything, which is also fine for now. Okay, so the first thing we need to do is we need to make a set, right? So we're going to say const letters equals, turn this off, and I'll get into this as well as another useful feature. Okay, so const letters equals, we need to make a set here, but if we just say like this, then the problem is we want this to only take in strings. So we don't want letters to add, like 5. But right now that works. So we want to make sure that doesn't work. So we actually want to give this type to this letters. And the way you do it, I think, is you do set. And then in these things, you can write the type that you want. Kind of like in the object, you can have a key value pair. So we just say we only want it to take in strings. And so now if we do letters dot add 5, see what happens. Argument of type number is not assignable to parameter of type string. That's how you make a set that strictly takes in something, and then that way if you give it something wrong, it'll yell at you. And you can also, it'll also, if you try to add like undefined or null or something, it will also give you errors, which is what we want. Okay, now we're gonna need 2 more things. We're gonna need a left pointer, and we're gonna need a result variable. So let's make those. So let's result. And then the other nice thing we can do is, so I think in the two-sum, what I was doing is I was saying like let result number, but this is kind of actually redundant in TypeScript because if you make a variable and you assign it to a value, if you actually look at it, if we try to do like res equals something, the string is not assignable to type number. So when you make a variable in TypeScript and you assign it to something, the first thing you assign it to, as long as it's like not like an empty array or something and you want it to be a number array, as long as you assign it to something reasonable, it will remember the type that you assigned it to, and then if you try to assign it to another different type, it will give you a warning. So it's kind of like smart about recognizing what types you want. So we want result, and we also want a left. So we could just do the same thing for the left. Okay, it's being read just because we haven't used the values, which is totally fine. Okay, so now let's make a for loop, and in the for loop we're going to use the right. So we're going to say let right equals 0, right is less than string length. This is actually should be s.length. Okay, and we can increment it here. And also the nice thing is, I think I had a question about I think I had a question about like how it knew the type of the right. So actually it's kind of the same thing because we made our right equal to 0 here. If we try to do right equals like this, it should also yell at us. So you see it does. It says like the string is not assignable to type number. So now that we assign something to right, it has to be a number. Okay. And so now what's our logic? So we basically need to check if the right index is in our set. So we can just say like while the letters dot has. So has in TypeScript is how you check, or in JavaScript, how you check if something is in the set. And you do SR. So this is the right letter, the current letter we're on. So remember, what do we have to do? If the current letter is in here, we have to check is the current letter equal to the left letter. So we could just say like if this is going to be SL equals SR. Then remember, what do we have to do? We made our little optimization where we just have to increase left by 1, and then we can just break here, right? So let's do that. So we can just do L++, and we can just have a break. Otherwise, what do we have to do? We have to get rid of the letter, and we have to move the left. So let's do that. So here, what we'd have to do, we don't need an else because we have a breakpoint, so that's not needed. So what we need is we need to get rid of the letter. So I think it's like letters. Nice thing about VS Code is I guess it'll tell you. Obviously, you know, I guess this is a downside about using this for LeetCode, but it's okay because we're mostly practicing TypeScript. Okay, so letters.delete, and then we have to get rid of the letter. So it's going to be SL. And now you do L++ as well, and you keep doing this until you hit this case, and you are guaranteed to hit this case eventually if you have a duplicate letter. Okay. So after this while loop, we have a valid string. So now what we need to do is we need to maximize the result. So we could say res equals math.max of res, and the way to calculate the length of the sliding window is right minus left plus 1, right? That should be pretty common. Okay. So we have our result, and we're still getting an error, right? Because we're not returning anything. So we need to return. And let's just make sure we're returning like in the right spot and stuff. So it looks like we are. And we need to return the result. And so what we want to do now, actually we're still getting an error. Let's see. Function lacks ending return statement, returns types includes undefined. Okay, that's fine. Let me just make sure this is, oh, all right. So this needs to be, this is in the wrong spot. We need to be returning over here. Okay, there we go. So we could just like put it back into LeetCode, but another thing I wanted to show you is you can get this extension called Quokka, which is really nice actually. So you get Quokka and you get these Quokka status bar buttons, and what it allows you to do is if you just hit this Q+, it'll tell you like, so this white means that your code hasn't ran, and it makes sense because this is a function that we never called. But if you do something like call it, and let's just set a variable equal to that. So let's just say let result equals calling that function on, and then we could try some string, right? So we could try like A, B, C, B, A, C, A, or something. And then if we actually print it, it will tell us what our answer is. And so does that look right to us? Definitely not, right? So we definitely have an error here. And so let's figure out what that error is. Yeah, so we definitely have an error because it's giving us 11, which is like the length of the string. 6, 7, 8, yeah. So we definitely have an error. So maybe what other thing we want to do is maybe we want to print the left. So we could do that as well, and we could try that with a shorter string. So we could just say like, just print the left maybe here. Left. Okay, so you can see it's never being updated. And why is that? Oh, it's because, right. So so we did run into an issue, and that's because we never actually added the right value. So our shortcut was if the left and the right are the same, then we're just going to break. But the problem with that is we're never actually adding new values in. So where would we want to add new values in? We could just add it in up here. I think that should work. So we could just say letters.add. But you could see it's like super convenient for debugging. So we could say SR, I believe. Now let's see what we get. Okay. So now we're getting 0. Right. So the other problem is, yeah, so we don't want to, yeah, we definitely don't want to have it there. Definitely don't want to have it there. I think we want to have it down here, but then we are doing repeated work. But I think that would work because essentially if we add it up here, the problem with that would be it would always be in there. So you want to add the letter in at the very end. But, I mean, this is technically fine. But we could also just delete our letter, but we could just leave it like this. Like either way is fine. It's not a big deal. Okay, so this is totally fine. And if you like, yeah, we didn't want to delete and add letters. Honestly, I feel like just deleting is probably better. It's a little bit less. So I think we could just delete it and get rid of this thing because it's not really an optimization. Like we're just saving one delete, so I think that's totally fine. Okay, so now our string is correct, and we could try a couple like just to test things. So we could try like a totally unique string of, so like all these are unique, and you can see like every time we add a letter, we are getting something expected, and then we could do something like this, which also works. And then we could do like, you know, power or something. These are all unique. So now we have a valid solution. And that's the nice thing about Polka is if you, and this is only the free version. I think the paid version does a lot more things, but essentially you can write all your variables, and instead of having to like run your stuff, it'll tell you what the values are like right away, which is super convenient. Okay, so now we know that like our function is good, and now we can leave this, I guess. So what we want to do is we want to run it in the terminal, and so remember the way to do that would be you can do a couple things. I think you can actually just say node, so you can run it like this: LeetCode problems.ts. So you could do that. Let's see what happens. It's okay. So it said not found. So maybe you can't do it like that. Let's just double check. Yeah. So I think you might have to just do that npm start because you might have to use the compiler. Okay. So that did work. Yeah. And we can test it. So we can just like console log or something. So if we run that one more time, so if we do node, we have a problem, but if we do npm start, then we are getting an answer. So essentially, remember from our code, what we do is we call the Typescript compiler, and then we run the JS file. And so you can see there is a JS file. So this is what our file got turned into in JavaScript. Yeah, and it's just saying use strict because we are simply just using strict. But yeah, at any point in this thing, if you change your types, it would should give you errors. So that's exactly what we wanted. I took out the undefined because I think it was a little bit too much, but I think this is pretty good. Okay, and then I think what I'm also going to do is I'm going to just like make a GitHub with all these problems, so then I can send a link to that. But let's try to actually put this into LeetCode just to make sure, like, right? We did a few tests, but who knows, right? So let's put that in and see if we have any issues. Oh, looks like we have an infinite loop. Oh no, I guess it just took a while. It's like, how do you have an infinite loop? Okay, and so you can see it was reasonably efficient. And yeah, I think we can go through the time and space complexity really quick. So for the time, it's a sliding window, so that's going to be O of n. Oh yeah, I'm not in Python anymore. Okay, so and for the space, we made a set, and so the set, worst case scenario, can have 26 unique letters, which is O of 1 because it's only 26 letters max. And then these are all constants. So space is going to be O of 1, time is going to be O of n. But yeah, it's going to be it for this problem. So if you did like it, please like the video, and I will see you in the next Typescript problem. Thanks for watching.